Hi everybody, it's Ms. Lorenz. I'm going to talk about lesson 3 for unit 1. This lesson is a lot of finding area and being really creative with our strategies for finding area. So in number 1, you're reminded that each grid square is 1 square unit, and for each of these we have to find the area without counting every single square. And so in A, you can see that what I did was break this or decompose this into a 3 by 2 and a 3 by 6. 3 times 2 is 6 and 3 times 6 is 18. So we're simply adding 18 and 6, and so we get 24 units squared. In B, I also decomposed it, so I have this rectangle, which is 2 by 4, and that of course is 8. This rectangle, which is 2 by 6, which that of course is 12. This little rectangle on the side is a 1 by 4, which is 4. And this little tiny guy down here at the bottom is a 3 by 1, which is 3. So I'm simply adding 8 plus 12 plus 4 plus 3, and I get 27 units squared. All right. In C, you can see that I really decomposed this. I thought this was a fun one to do because the square is tilted, so it's a little bit hard to find the lengths of the sides, but that made it more fun to use the triangles. And so what I did, since we're finding the area of the 4 triangles, I noticed that all 4 of them are identical, and that each one is exactly half of a rectangle. Do you see that? So the rectangle's dimensions are 2 by 4. That's why I wrote 2 by 4 here. And then the triangle takes up half of that rectangle, so if we divide that by 2, we end up with 4, because 2 times 4 is 8, half of 8 is 4. But then we have 4 of those triangles, and so 4 times 4 is 16. And then in D, it kind of relates to C, because D has like the opposite situation. So the square inside is the part that is shaded. So I just re-surrounded D with a square that's 6 by 6, which would be 36. And then I'm subtracting the 16 because we already figured out that the area of these 4 triangles summed together is 16. So we're taking 36 minus 16, which of course is 20 units squared. All right, more area problems. So in this first one, we are finding the area of a parallelogram, which we know is found by taking the base times the height, or 3 times 5, and we get 15. These are centimeters, so we're going to label it accordingly, centimeters squared. In B, we are going to do, well, there's lots of different ways you could do these, you guys, so just take note as you're correcting your work how I did it. So in B, we're separating this this square into some triangles, because or rectangles, because I noticed that each of these 4 triangles are identical in size, and each of them is half of a rectangle, and they're actually the same as what we would have found in that previous problem had we done it this way, which we are. So I'm just going to multiply 2 times 4 because it gives me the area of the entire rectangle. And then I'm going to divide it by 2, because remember, dividing it by 2 leaves me with just the area of, where'd my pen go? Just the area of the triangle, because a triangle takes up half of the rectangle. And so 2 times 4 is 8, divided by 2 is 4, and then there are 4 of them, so we get 16. These are centimeters squared. And then C, we're going to do something similar. We're taking the entire area of the square, which is 5 times 5, or 25, and we're subtracting out the area of the smaller square that's inside of it, which is a 2 by 2. So we're subtracting away 4, 25 minus 4, we are left with 21 square centimeters. All right, in number 3, you are to find the area of each shaded region. Show your reasoning. You can see that I decomposed this first one into, first of all, a 2 by 5 rectangle, which gives me an area of 10, and then a 2 by 4 rectangle, which gives me an area of 8, and a 2 by 2 rectangle, which gives me an area of 4. And so I'm adding 10 plus 8 plus 4, which gives me a total of 22. These are units because they don't distinguish whether they're centimeters or inches or whatever. So if they don't distinguish, you just write units squared. You still always have to label in square units. All right, in B, I took the entire square, which is a 6 by 6, and then I'm going to subtract 2 groups of 2 by 2 because there are 2 by 2 squares. So I'm going to start with my 36, which is a 6 by 6, and then when I'm subtracting 2 groups of 2 by 2, I'm subtracting 2 groups of 4, which is like subtracting 8. And when I take 8 away from 36, I'm left with 26. And these are units squared. Oh, 28, you guys, not 26. All right, and then in C, I did a little rearranging on this one. So I'm taking this little triangle over here, and I'm moving it over, so it's going to sit right here, and then that allows me to look at that as a rectangle that is 2 by 3, which is 6, and then this rectangle down here is a 2 by 6, which is 12, and then 12 plus 6, of course, is 18 units squared. All right, keep on keeping on. Number 4, find the area of each shaded region, and we'll just keep on showing our work. Let me choose a different color here just to mix it up a little bit. What do you guys like for colors? I should ask you. How about a purple? Yeah, let's do purple. All right, so this square, you can see I decomposed it. So this square is a 2 by 2, which is 4. And then this rectangle right here is a 4 by 6, which is 24. And 24 plus 4 is 28. These are centimeters squared. This one, we're starting with the 5 by 8 rectangle, which is 40. And we're subtracting the little guy inside, which is a 2 by 3, has an area of 6. And 40 minus 6 is 34. These are square centimeters. This one at the bottom kind of looks like a swimming pool to me. So we're going to do the outside, which is a 15 by 10 or 150. And then we're subtracting this swimming pool that I'm coloring purple, 9 by 6, which is subtracting 54. And so we are left with 4 less than 100, which is 96 centimeters squared. And then lastly, I'm going to decompose and rearrange this one. So in D, I notice it looks like 2 triangles put together. So let's move this one, since they're identical, over here. And now we have a rectangle that is a 5 by 8 rectangle, and a 5 by 8 rectangle has an area of 40 when these are square centimeters. All right, last one. 2 plots of land have very different shapes. Noah said that both plots of land have the same area. Do you agree? I agree. So here's why I agree. Because this chunk right here, even though it is not existing there, it gets moved here, but the area remains the same. So that area just got moved, but it did not change. So I hope that makes sense and that your explanation here reflects that. All right, hope everybody's doing well. Thanks for listening.